Hi, today we're going to talk about comparing probabilities. So, what I have is just a whole bunch of notes on my screen that I want to kind of go through with you so that you can see what I'm talking about. So, here I have a problem. There are 15 girls in a class of 28 students. A, what is the probability that a girl gets called on? B, what is the probability that Jane, a girl in class, gets called on? So, probability of a girl, right? We just do 15 over 28 because there's 15 girls in the class, there's 28 total students. Okay, that's the probability of choosing a girl. It ends up at, looks like it's almost 54%. That's the probability of choosing a girl, a little over 50% of the chance. But specifically, what about the probability of choosing Jane? Well, Jane's only one person out of the whole class. So she's just one out of 28, which ends up closer to just 4%. So then the question is, but Jane's a girl, so why is the probability of Jane so much lower than the probability of choosing a girl? Well, it's because there are 15 girls in the whole class, so 15 chances to choose a girl, whereas Jane is just one person in the class. Now, let's say every single girl in the class was named Jane. What's the probability of choosing a girl named Jane? Well, then the probability is going to be the same as the probability of just choosing a girl because there's 15 Janes in the class. But again, even though Jane's a girl, that doesn't mean her probability is the same as the probability of choosing a girl because she's just one person. So that's the first question I wanted to go over. Now I have another question. After doing an experiment, Sam noticed that a spinning penny landed on heads 40% of the time and tails 60% of the time. So a spinning penny, imagine we have a penny and we just kind of, spin it, spins around on your desk, and eventually it lands. Okay? Well, we know a penny has just heads or tails. So there's only two choices. So really we would expect it to be 50-50. We'd expect half the time it to land on heads, half the time tails. The question is, do the outcomes of spinning a penny appear to be equally likely? The reality is we cannot answer based on this information. We need more information. Because what if he only spun the coin 5 times? Well, then 2 times were head, 3 times were tails. It looks like it's about 50-50, right? Next time could have been heads, and so it does end up 3 times and 3 times. Okay, so then yes, it looks like they're equally likely based on that. But what if he took the time and spun the coin 1,000,000 times? Well, then 40,000 times are heads and 60,000 times are tails. And in that case, the gap is so different that no, we do not expect it to be equally likely to spin a heads versus a tails. So really, we need to know more information. We can't just know the percentages. But here then it asks, if they're not equally likely, let's say this second scenario is true. They're not actually equally likely. What could be a reason? Because we thought it's supposed to be 50-50. What's up making it so they're not equally likely? Well, honestly, one pretty clear answer could be that maybe the coin is weighted. When we spin it, it's slightly weighted more, so it falls down so that tails shows more often than heads. So that's one reason that I would think that it's particularly could be more likely to show tails than heads. So that's an example of comparing probabilities.